Hello students, this is Ashini from Cheenta.com. Today, I'll talk about a very interesting problem in number theory. It's an easy problem, but we can learn a lot from this one single problem. Basically, we'll talk about two different things. Form of a number. So if you're just starting with number theory, this will be really useful. And second, quadratic Diophantine equations. Diophantine equations are equations with integer solutions. It means suppose we have this particular equation, x squared plus y squared equal to 2015, and we want to know what integers satisfy this equation. So if I plug in x equal to some integer and y equal to some integer, will it satisfy this equation, and how many such pairs of integers are there that satisfies this equation? Those type of questions are related to something called Diophantine equation, and both of these strategies are useful for mathematical Olympiads like IOQM, American Math Competition, ISI-CMI Entrances. So if you're interested in this, follow along. The link in the description will contain a quiz question, so you can also try that and have some fun with it. If you are new to this channel, welcome. This is the space for mathematical sciences, Olympiads, research for school students and college students. We have a lot of fun with these programs. Check the link in the description for more details related to these programs. So look at this now question. X squared plus y squared equal to 2015. We are given that x is greater than or equal to 0, y is greater than or equal to 0. And we want to find out the number of integer solutions to this equation. So to do that, what we are going to first talk about is something called form of a number. Form of a number. So let me write that. So if you look at any number, any square number, then the form of a square number is always either 4 times some quotient, or it's 4 times some quotient plus 1. Any square quantity can either be of one of these two forms. Remember, if you divide a number by 4, the possible remainders are 0, 1, 2, and 3. Any number can be written in the form 4k or 4k plus 1 or 4k plus 2 or 4k plus 3. But when it comes to square numbers, we have only these two forms. Now, why is that? It's actually quite easy to prove. Here is a quick proof of it. Any number is either even or odd. Even means it's 2 times something. Odd means it's 2 times something plus 1. Think about it. Even numbers are twice of some other number. That's why they're even. And odd means it's even plus 1. That's why it's odd. The way of writing numbers in the abstract sense like this is known as for manipulating the form of a number. It's very useful in number theory. Now, if you square these, what you'll get is this one becomes 4k squared, and this one becomes 2k plus 1 whole square, which is 4k squared plus 4k plus 1. Right? Now see, if I analyze this, this one is 4 times some quotient. Right? This quotient is of course k square here. And this one is 4 times some quotient plus 1. And this quotient is, if you take 4 as common, this quotient is k squared plus k. So what I just showed you, that any square number produces either 0 as remainder when divided by 4 or 1 as remainder when divided by 4. The other two cases, 2 and 3, does not happen. Now let's use this idea to solve this quadratic Diophantine equation. X squared plus y squared equal to 2015. Now notice that 2015 produces 3 as remainder when divided by 4. You can easily check this by looking at the last 2 digits. 15 divided by 4 produces 3 as remainder, and that's like the divisibility check of 4. You check the last two digits, what's happening there. So 3 as remainder when divided by 4. When divided by 4. Now let's look at the two square quantities on the left hand side. X square can produce either 0 or 1 as remainder when divided by 4. We just saw it. Any square number produces 0 or 1 as remainder when divided by 4. And y square produces 0 or 1 as remainder when divided by 4. So, the sum of the two square quantities can at most be 2. The remainder, if you add them up, the highest possible value of the remainders sum can be 2. If both x square produces 1 as remainder and y square produces 1 as remainder. It can never be 3. So there is no solution to this particular equation. Isn't it interesting? If you think about it geometrically, it's like this. X square plus y square is equal to 2015 is actually equation of a circle. And the radius of this circle is square root of 2015. What we just showed is that there is no coordinate point on this circle. There is no coordinate point on this circle where both the coordinates x and y are integers. This is sometimes say it like this, that there is no lattice point on this particular curve. This curve is a circle. There is actually a very important problem in advanced number theory as well, where you want to know whether there is a lattice point on a certain curve. Lattice point means, in this particular case, both coordinates being integers. Okay, I hope you learned something from this video. If you did, please share and comment. Thank you for watching. I'll see you in the next one. Take care and bye.